I am delighted to be able to present two fantastic speakers to you today. Sujay and Sathwik from Malwarebytes. We've been working with these guys for a long time. And it has been our pleasure because I can tell you, without having had the benefit of their experience, their understanding of the market they're in and what they've been trying to do, there's no possible way we could have made our product Control M as good as it is. So without any further ado, you don't want to hear from me, you want to hear from them. Let me please introduce, give a warm welcome to Sujay and Sathwik from Malware. Thank you very much.
Good morning, everybody. Thanks for coming. I know it was a long walk. At least I took my break. I'm Sujay. I've been around the industry for about 12 years now. Spent most of my time at Apple doing the same thing on different technologies, though. Spent about 7 years there. Then I spent a lot of time at GoPro, and now I'm with Malwarebytes for the last 2 years. So in today's session, for about 40 minutes, we'll try and cover what we do, who we are, how did we do it, what are the important learnings and lessons on our journey into cloud, what we're doing currently, and what do we see ourselves doing in the future, in the immediate future, I would say like 6 to 8 months. This is a short video. Yeah, we're definitely not good at making videos, but that's our mascot. Thank you. So that's our mascot trying to do, what we do, like kill malware. So this is our very old 27-year-old CEO, Marcin, and what he believes is what we all believe in too. Everyone has a right to malware-free existence. This is our mission. What I would want you guys to look at is this part here, because every day is a 0 day. So I'll talk about what is a 0 day and show a few things in the slides to come. Some numbers, I don't want to spend too much time on this. We see about 500K unique downloads every day, and we have saved about 1.5 billion IT hours, and we protect close to 20,000 plus businesses, because we do have consumer as well as business offering. I know you guys didn't come here to hear about Malwarebytes, so let me get started about data science and engineering. So we estimate that on any average day, we see about 1 million different variants of malware released into the world every day. I know this number looks daunting, but there's days when it's more than this. For a common man, it's difficult, but since I've been in the industry for 2 years now, this is something that we see on almost every day basis. So what's Malwarebytes' unfair advantage? This is a glorified representation of a freemium product. So there's a free product offering, and there's a premium offering as well. Even now, since from the day one, if you have any problem with your computer, any virus, Trojan, you can go to our website, download our product for free, and use it for remediation, and continue to do so for as long as you want. It's only when you want to unlock some additional features like real-time protection is when you have to pay and go for a premium offering. So what this has done, offering products for free for years, is it has put us on this like freemium freeway. We see like hundreds and thousands of installation happening like almost every day, and all these systems that are spread across the world send telemetry back to us. Of course, in an anonymous way. We get to see a lot of data. In fact, it's big data. I don't know if it's data or big data, because these days the trend is to use the word data. They're moving away from big data. But then we get to see a lot of data. Just to put things in perspective, I would like to share some numbers that we see on day-to-day basis. We receive about 1.2 billion unique requests per day. That translates to processing about 500 billion records every day, which again translates to about 2.5 trillion processed records. I'll talk about what this means a little later. And in the last 18 months, we have amassed about 50 petabytes of data which have analytical values. So there's just too much in a day, and a lot of us like to work only like 8 hours a day. So how do you deal with this volumes of data, this complexity? We built something called as RTIs, real-time indicators, depending on multiple parameters like threat velocity, attack vector, geographical impact, etc. So what this does is it basically crunches all this data and bubbles up the top 1% that a research team needs to focus on day-to-day basis. So for all those of you who are new to following cybersecurity industry, the world of black hats and white hats, just to let you know a little bit, the world of black hats is getting very sophisticated these days. So there used to be people who are smart enough to write viruses and deploy it in millions of systems. But now, as the world has evolved, they have made up into two groups. There's guys who are good at writing viruses, Trojans, rootkits, backdoors, etc. And there's guys who are good at deploying that. It's called exploit kits. So the people who develop exploit kits, their job is only to make sure they consume the virus code and then deploy it across millions and billions of systems across the world. I mean, it's fascinating the way that industry has evolved. They have gotten to a point where the exploit kit owners even give you a money back guarantee. Like, give me a piece of malware, and if I don't deploy it to, let's say, 500 million computers in first 3 hours, I'll give you money back. So it's gotten to that level. So what happens is all these malware attacks go in campaigns. Okay, I'll just like to show a little bit, about how this campaign lifecycle looks like for most of the, very harmful malwares that we see. So what you see on the y-axis is impressions, or read it as the number of systems impacted in millions. And this is the hours, number of hours, 6 hours, 12 hours. And this is day one, and then day 1.5. So if you look at one of the samples, what you see is this malware pretty much lasted for about 18 hours, but it did all the damage in the first 6 hours. And then it just faded off. Take a look at another example. It lasted for about a day, but did most of it damage in the first 12 hours. And few other examples. This lasted for a little more than 18 hours. This thing went on for about 1.5 days. So what you see here is basically, if you're not fast enough to get to the insights into all this data and action it within the first, let's say, 6 or 12 hours, it's pretty much game over. I mean, anything you find after a day is, I would say, good for blogging. It's not good for an antivirus company. So what are the challenges to getting into insights for huge data sets? A lot of you guys know, have heard about these things like V's of big data, like velocity, volume, veracity. I would like to focus a little more on this part, like information density. So unlike those old days where a lot of accounting was done in XLS, every single row meant something. So that's not the same in big data, as all of you know. The information density is extremely low. Like, we have to crunch like petabytes of data to get to something which has any significance or any statistical significance, I would say. So it has to go through very sophisticated systems and processing to get to a point where we can use it for something. And there are other challenges, like there's new skill sets in the market, and there's old technologies and new technologies that you need to deal with. There's cost associated to that. And of course, there's all those legacy systems that you can't get away with. Just to look at the technology space, in the big data world, this is how it looked 10 years ago. A lot of you people know about like Hadoop and Hive, HDFS, Apache, and then like 2 years from there, things started popping up like Flume, HBase, Cassandra, Scoop, and then came all these in-memory technologies like Cloudera, Impala, Spark, message broking, and real-time streaming, Kafka, etc. So basically, this is the state of big data technology evolution currently. Just at Malwarebytes, this is how naive our architecture looked about a year back. We had few things here and there, and that was good for us then. But now it looks crazy. I mean, we have almost every known thing in the world of big data, and I've tried to put in a lot of things there, but I think you get the point. You need to keep evolving continuously. So we talked about these challenges a little bit, V's and landscape. What do you think is even a bigger challenge that usually goes unnoticed? We think it's agility. So I was putting together some slides to make it little more relevant. This is something that I came up yesterday, trying to draw a correlation between how being an agile team can save you costs. So back when we started, we were on Cloudera platform. Is there anyone among the crowd who have had an experience of worked or currently have an experience working on Cloudera big data platform here? Yeah, I think there's a good reason for that. So this is how it looked. We had Cloudera Impala, a lot of things on Amazon Web Services, BMC, and a couple of other things. So like I just talked about, we processing about 50 petabytes of data. So imagine doing that with the way we did it in Cloudera. So we were on-prem, and it was a persistent cluster, 24 hours running. And just to fit in all this data set that we have right now into 3, that's the replication factor that's recommended, we would need about 18,000 data nodes, that number of EC2 instances that we need to keep running. And very soon you realize MapReduce is not an efficient way of querying analytical or tactical queries, but it takes time. So what Cloudera would recommend is have a separate cluster and shove in all of your data there, so that you can use the in-memory technology. And we would need a lot of Impala nodes to fit in like 150 terabytes of data. And just doing a simple math, I came to this figure like about a little more than 7 billion per annum. There's some Cloudera licenses cost associated as well. So for a company of our size, this is make or a break deal. We can't survive just by buying more nodes and scaling. This doesn't work that way. So we were agile. We adopted a lot of new technologies, did a lot of refactoring and re-architecture. So this is a real number. This is what our Amazon bill looks like for the last month. And then if I extrapolate that for 1 year, it would be around 319K. Of course, there's few costs that I have not calculated here. What I'm trying to say is, just by staying agile, we have saved a lot of money, like probably at about less than 1%, I would say, than what we would have been if we had not, changed technology or architecture. In fact, talking about agility, even our data science and engineering team logo has undergone 3 different changes in the last 18 months. So how do we stay agile? So this is a very high level view of what are the key components of our architecture. So Amazon Web Services happens to be one of those pillars, and Control M, this is a workload automation tool that we use, also happens to be the other key component of our architecture. So if you look at this way, Amazon happens to be the white canvas, and let's say the Control M that I'm talking about, the workload automation tool, happens to underpin everything we do within AWS. Let's take a look at how we do it. So this is how our components and architecture looked like about 1.5 years back. We had Hadoop, Cloudera, on-prem, and then there's MapReduce engine for processing data, there's Tableau for dashboarding, and a couple of other small components in the architecture. We moved from on-prem to hybrid cloud, and then we moved from hybrid to completely fully into cloud. We changed few other components here. I mean, what you see here is the ease with which we are able to rip and replace, or let's say peel and replace technologies without having to touch the core components of a framework. So we do everything in cloud. We are 100% cloud native. That itself will give us a benefit of staying agile. But this other key component that has really helped us achieve this is the underpinning workload automation tool that I was talking about. And then you see AWS Glue coming in for ETL. Amazon SageMaker for all this machine learning and AI stuff. Then we have found something called Looker for BI stuff, etc. So did it work out well for us? It felt like a long day at office, but then I think we were able to achieve what we had planned for in almost every single quarter. So I would like to spend the next few minutes talking about and showing few things that we think are cool projects and we are really happy and proud about showing. So for all those of you who know and understand the Windows operating system very well, there's something called as Windows registries. So every time you install a product like an antivirus product, you have to make an entry. Basically, you have to register yourself into that module. So as an antivirus company, if I go and look there, I can easily find out who else is installed alongside my product. And as I said, we get a lot of anonymous telemetry. So we know exactly who is installed on our customer, who else is installed on our customer's computer, and what are they missing that we are catching. I mean, what are they missing that we are having to go and clean up on every single day? So this is something that we built for our sales team as a conversation starter. So you walk into a client's office and then you ask them, like, what is the current AV that you have, antivirus? And they say AVG, Norton, or like there's hundreds of other things. And then they just go here and they click that, let's say AVG in this case, and they hit a go. So this guy just ran some queries in the background and built this report. So what this means is out of the sample of machines, like 3.5 million that we chose, there's about 30% of the machines on their domain that are infected currently. I mean, this is what we had to clean up that they missed. And it even drills down to the level of what they missed, like Trojans and rogues, backdoors, rootkits, and they are pretty nasty ones. Unlike virus and malware is a common term, but these are pretty nasty ones. And sorry. It also shows all the breakdowns, like you click on ransomware, it shows what are the families and subfamilies of ransomware that AVG missed that we had to go and clean up. So this is for velocity, how fast a malware is spreading, what types of malware are popular for today, what is relevant for today in this hour. So this is the leaderboard that we call malware detection leaderboard. So if you look at it, this is last 30 days, last 7, yesterday, and last 4 hours. So what was trending yesterday doesn't necessarily trend today, because it talked about these campaigns, right? Like you see a campaign today, and tomorrow you release a patch for it, it may be totally irrelevant. So let's take a look at this. So there's two pieces to it. We use it's kind of a pseudo lambda architecture. One of them takes care of dealing with what we see right now. And there's other aspect to it where we heavily use control M for processing, which mines the data and plots all this, like what happened in the last 7 days. This gives us interesting stories about anatomy of different malwares. Let me play this video, and then there's a couple of other interesting things to talk about this. So this is how they spread across the world. Detections happening. The color is showing the type of malware. And we have built something called as Threat Data Lab. This is just like a leaderboard, but gives you more controls. Like you can filter it by geo and type of malware, etc. Let's take a look at Germany, and then let's choose something like ransomware. So ransomware phantom is something that is trending in the last hour, and this is specifically in Germany. And what you don't see here at the bottom is there's a couple of buttons which can show you how it propagated. So these are the detections of that ransomware WannaCry that you have been hearing in the news, that you have heard in the news in the recent past. This is how it appeared in Germany. And if I remove that filter for Germany and see how it's spread across the world, it has an interesting story. You'll see why. I'll go back, I'll remove the filter. There's no country, it's just the whole of world. This is from our vantage point. And you'll see these guys have been, the creators of WannaCry ransomware, they have been testing all across the world. This is their pre-release phase, I would say. And then once they're happy with what they see, there was an outbreak. There's a sudden global outbreak, like almost everywhere it had spread. So this is where we saw it first, the red dot, Ecuador. Again, this is from our vantage point, from all the telemetry that we get from the systems that have installed Malwarebytes. So let's take another example. It's called ransomware Petya, that not all of you guys may be aware of or heard of, but this is as nasty as ransomware WannaCry. Now this has a different story. Like there's some malwares that come in multiple campaigns. Like I'll show you how this works. Like this was majorly being tested in Germany with few exceptions. And then you'll see the first campaign, the first outbreak that is predominantly affecting central Germany. So people then, learn to live with it, pay up for it, install some antiviruses, move on in their life and forget it. And then what happens? So these guys go tweak their code a little bit, make it look a little different, and then they'll come back again with a second campaign. You'll see that. See, this time it was a global release, right? And then mostly it was impacting the America and I would say Eastern America mostly. So there's no guarantee of what will happen. We hope that they don't attack APAC or ANZ next. So just by looking at a combination of what's happening now and what has it done in the past, it gives us a good story of what these guys are thinking. So it's all about cat and mouse game. Like we stay ahead of them, they stay ahead of us, and that goes on day in and day out. So all those traditional antivirus companies who work based on signatures, like you find something, you write a signature. The next time if you don't find the signature, you'll never know if it's the same thing. So they keep missing a lot of things. We don't work that way. We work a little different, in a little different fashion, most of which is driven by AI and ML. It's based on like heuristics, behaviors, etc. that we are able to catch something on day zero when it actually happens. So I'll spend the next few minutes to talk about our AI and ML initiatives. We are very early in this journey. We've just been around there for 2 years, and it took us 18 months to build the data lake and have all the plumbing done. It's only now that we are able to harvest a lot of ML and AI, and a lot of guys have been talking about ML and AI in the last 2 years, but there's very few guys out there who are actually doing stuff in this. So I'm not a very comfortable speaking about these things because I'm still learning, but there's few things that we do that have had a huge impact on business. One of them is opportunity close to one model. So given an opportunity, like what is the probability that this will convert into a business, and how long is it going to take? So there's a lot of verbiage there. Let me just focus you guys on this thing. So we took a sample of about 346 opportunities, and what you see here in this total column is number of opportunities, not one, 290, and one is about 56. So we ran through multiple models, multiple training, and what we're using currently is this Cox proportional hazard model. People in medical field would know about this. This is giving us great results. Like if you see the green box there, out of 290, we were able to predict 283 of them accurately. And for the one cases out of 56, we are able to predict about 50 of them accurately. So given an opportunity with very high degree of accuracy, about 95% plus, we know what are the chances of it converting. And so is the case with number of days for conversion. That has translated into building us something that we call as a sales playbook. So the sales guys go into the office every morning, they'll take their phone, look at the diary, and start calling all these prospects. That has changed slightly since we built this. So now what they do is they go into the dashboard. I mean, it's not fancy though, it's the first version, but there's something called as an AI score that is sorted in a descending order based on, let's say, lead propensity of conversion. So what they need to do is just go and start calling from top down. We have been able to prove that by adopting this model, we have increased the revenue by about 28 to 29%. So that's a job well done for first version. We do a lot of hierarchical clustering, like ransomware, WannaCry, ransomware, Petya. So what happens is when you get a piece of malware executable, in a controlled environment, we detonate that. And it exhibits a lot of behavior, like it tries to take admin privileges of your computer, it tries to lock your files, and it does a lot of things. So depending on what it is trying to do, we try to cluster it, and then we know this is like cluster 1, this is behaving like XY, because they don't come with name, we have to name them. It comes and it exhibits certain behavior, makes some damage. So, and also we use a lot of variant distribution for labeling the data. Like what you see here is a human labeled data for a given data set. Like so many look like Cerber ransomware, so many look like Locky, and so many look like WannaCry. This was a first try. This was a second try with a different clustering. And now we use something different, and we are able to very accurately predict based on the behavior of a certain piece of code. We know what it's like. Is it like a Cerber or a ransomware, etc. And we do a lot of, we realized on the way that it's just not AWS. There's a lot of good outside of AWS, like for natural language libraries. Probably at this point, I think Google is the best. So we hooked up to Google, and then we do a lot of sentiment analysis. So what I would like to say here is, before I hand over to Sathwik, is we have been, in the morning, if you have attended the keynotes, I forgot the name of the gentleman, but he was talking about how difficult is it to architect something at this scale. And he also mentioned that the best book about architecture is yet to be written. So what that only means is you'll have to keep changing, you'll have to keep learning. So it's really important to stay agile and figure out what are those key components that will help you, embark on this frequently changing journey. So I would like to hand it over to Sathwik to do a little bit of deep dive on how we actually do it. Just be with us for a minute, please.
Thank you, Sujay. Hi, my name is Sathwik. I'm a big data engineer at Malwarebytes. I have been part of Malwarebytes for about a year and a half now, before which I was part of business intelligence team at Apple, working mainly on the EDW projects. So I'm one of those guys who have been through the journey of transition from traditional data warehousing to big data and big data on cloud. Let's move ahead. This is about me, which you don't want to see. So I wanted to skip that slide. Okay. So Sujay talked about a major challenge for us at Malwarebytes is staying agile, adapting to the new technologies, the cutting edge technologies, and at the same time making sure that our deliverables are not impacted. So this has influenced our choice of architecture for the data engineering, and like Sujay said, the key components are AWS and Control M. So most of us here know that AWS has a bunch of services on cloud. In fact, you think of any of the cloud-based service, and AWS has it today. So I'll not talk much on AWS and spend a little bit of time on explaining how we use Control M and its features to stay agile. Okay, if you look at the ETL services that we have used since we started as a team in last 18 months, it has changed continuously. So we were on-prem before with cloud era, and then we moved to a hybrid architecture of cloud and on-prem. And our next step was operating fully on cloud. And in the next phase, we were aiming towards ephemeral computing, for which we used Kubol. At this time, we were totally cloud native, and AWS S3 was our storage in the cloud. So Kubol looked like a right fit because it was leveraging EBS and EC2, which are AWS services, and it could operate on the data that is sitting in S3. And and I think around this time last year, AWS came up with a fully managed ETL service, which they called Glue. And we tried it like 6 months ago, and we are currently running both on Kubol and AWS Glue for our ETL workloads. From the processing framework standpoint, that has changed too. Initially, we used MapReduce for all our workloads, and then we adopted to Spark because of its fast processing capabilities, and it could coexist with MapReduce. And recently, we have also been using Apache Tez because of its fast processing capabilities, as well as it's considered as a successor for MapReduce. So today, our workloads use all these frameworks. So here is a snapshot of one of our ETL workflows when it was built and how it looks now. As you can see, and this is a control M workflow where you can see all the jobs and the sequence in which they perform. So as you can see, both look identical, right? So how did we do this? How did we make sure that changes in the technologies did not affect our workloads? So we did it in a couple of ways. Just give me a second here. So we had our own micro frameworks. Then we used some features of Control M like connection profile, templates, as in job templates, and application integrator. I'll explain how these work. So with help of these, we are able to use Control M and connect to all the services and applications that we use, and control and schedule them in an appropriate manner. I'm sorry, I moved too fast. Okay. So the first one is pretty much every engineering team does. So we have our own frameworks to do a set of operations. For example, a bash wrapper script that connects to a system and performs a set of actions. So connection profile comes in handy when you have a lot of jobs that are connecting to a database. You can set up a connection profile to that database, and you don't have to worry about masking the password in the logs. And suppose you say you're using database A today, and you're migrating to database B, like MySQL to Postgres. You just have to change the connection profile, and all your jobs will run as is. You don't have to make changes in each job. Right. So next one is job templates, which allows us to create the job types for similar set of tasks. Like you can use a OS job type that Control M has to run all the shell commands on a Linux machine. The last one is application integrator, which is like a very frequently used feature these days in our team, because what we are able to do with that is, even though we have some services which Control M does not natively support connecting to, we are able to use application integrator and create those job types for these applications. And the key advantage of this is, even though we have so many applications and external services, we are able to monitor, control, and schedule them from one single place. That is BMC workload automation. So we have contributed some job types for certain operations. If you can see the AWS S3 operations, and uploading to a box folder, refreshing a Tableau extract. So where are we now? I would like to share something that we did recently. So let's consider a scenario where an analyst or a data scientist needs a custom aggregated data set for his study or a dashboard. And in typical scenario, what he has to do is he has to request the data engineering team to create that data set, right? And it gets queued to the data engineering team's list and gets serviced whenever they get time. So this might take anywhere around 1 or 2 weeks, and depending on the bandwidth of the team, right? So to address this, we came up with something called ETL as a service, which we were able to do using GitHub, Control M, and Jenkins. So basically, what we have here is a GitHub repository, which is configured with Jenkins for CI/CD. So all the user has to do, user as an analyst or a data scientist has to do, is to check out the GitHub repository and write some SQL code that is required to generate the data set he wants, and then also write a JSON file, which is the job definition of a Control M job, and then check it into the GitHub and commit it, and then raise a merge request to commit this branch, commit his branch into the remote repository of a main branch. And when the merge happens, it triggers a Jenkins job, which performs a set of actions like checking out the code from GitHub, copying it to an ETL system, then changing the necessary permissions, and checking the jobs, and dry running those with the help of automation API that Control M has, and at last send a notification about the Jenkins build status. So once the Jenkins build is successful, the Control M job would run at the next scheduled time, and make sure the data set is available for the analyst within a day. So with this whole process, we are able to reduce the turnaround time for the analysts from 1 to 2 weeks to about 24 hours, actually less than 24 hours. So how does our recent future look? So as a data and AI team, our focus is to have AI driving business and decision making. As Sujay said, we have already rolled out some solutions for marketing and sales, like lead scrubbing and scoring. And we have some chatbots rolled out to address some generic questions like, what are the malware detections today in country ABC, something like that. So next slide. Yeah. So this is an interesting infographic that I found online. So this can be looked as a AI adoption curve or a AI readiness curve. So it goes from top right and progresses towards top left. So the first part, which you can see in deep blue, is how it looks today, the AI landscape. And the last one is how it looks 3 to 4 or 5 years down the line. So not all the fields shown here or the portfolio shown here apply to every field. So we have adopted to few technologies here, like machine learning, chatbot, natural language processing, and sentiment analysis. And our goal would be to stay ahead of this curve and at the same time deliver value to the organization. So with that, I would say I would end the presentation and open it up for QA.
So I think we'll have time for one question if anyone has a question.